Okay, Caitlin, so question 14. Before I even look at the information that's given, I'm looking at the diagram, okay? So I see that there's a center, so that means that center theorems might be used, but because it doesn't go to a chord, none of them go to a chord. They all go directly to the circle without cutting any line. I know that line from center is not going to be a thing here, but because there are tangents, there's that tangent and there's that tangent, and they tell us there that there are tangents. Then I know that there are tangent theorems, and also that links to center theorems. So there's the center, and there's tangent theorems. Okay, so these are my theorems. There are no cyclic quads yet, but you'll see that a cyclic quad in this example actually does appear. And then I would start labeling what I know. Okay, so firstly, I would say that this angle is equal to this angle. Remember, I haven't even looked at the question yet, okay, because of tan chord theorem. Because there's a tangent, I'm looking for where I can apply tan chord theorem. And by the same rule, this angle is equal to this angle, okay? And then look in this triangle here. They've labeled that these two sides are equal. So if this angle is the blue angle, then that means this one must also be blue because it's an isosceles triangle. So we've already identified a link between this angle and that angle, that they are equal, okay? So immediately that actually tells us that AC is equal to PC. And if you want to write that on, you can. AC is equal to PC. It might help you later, I don't know. And then with tan chord theorem, we can also look at the other tangent, this tangent here, and say, well, this angle here must be equal to this angle. And likewise, I'm running out of colors, this angle will be equal to this angle. Okay, so there's a link. Do you see now we've got two angles that are, so like this one here, this B is equal to that one that I've done in pink, but it's also equal to that one. So that means these two are the same. But actually we know that because this is tan from the same point, which means that this line must be equal to this line. Okay, so the other thing we can do is we know that because of tan and radius, remember you're constantly thinking, because you see a tangent, you're constantly thinking back to what are your tan theorems. That means this is a right angle, and obviously that's a right angle, and this is a right angle because of tan is perpendicular to radius. Okay, and then suddenly you realize, hang on, what do these right angles tell us? Now we've actually got a quadrilateral here. Okay, so there's a quadrilateral that's formed, and this is probably the most difficult part of the question, is identifying. And whenever you have tangents from a point, I want you to remember that they often create, as they are here, two right angles at angle A and angle C, and two right angles in a quadrilateral tell you that that quadrilateral is cyclic. Okay, so actually here we've got a cyclic quad. Okay, so now I think we've written down enough on the diagram to start looking at the question now. So the question says circle with center O has diameter AB. Okay, so we're happy with that. There's diameter AB. A point P on AB produced, so AB produced means it continues to P, is chosen such that PC is a tangent to the circle at C, and BP is equal to BC. Okay, they've told us. And the tangents that they've told us that, the tangents to the circle at A and C meet at Q. Okay, so there's the point, and so we've already discussed that's equal to that. Okay, so now let's look what they're asking us to do. Okay, so they're asking us to show that OP, all right, so there's OP, is equal to OQ. Okay, so effectively, what they're asking is that we must show that this angle, let me just go back to my other pen. Okay, we must show that this angle is equal to that angle. Okay, whenever they ask you to prove two lines are equal, you always have to look at the angles opposite those two lines and prove that they are equal, because then you've proved an isosceles triangle. Okay, so now we've got to make the link. How do we make those lines to equal each other? And as I told you in the voice note, the key is in the new information that you bring out. So we've now shown that this quadrilateral AOCQ is a cyclic quad. Once you hear the word cyclic quad, you have to then think to yourself, what about a cyclic quad could I possibly use here? And the only things in a cyclic quad are opposite angles of the cyclic quad are supplementary. So these two, but we already know they're 90. And the other thing is that an external angle of a cyclic quad is equal to the interior opposite angle. And the third thing about a cyclic quad, remember that if a quad is cyclic, it means the circle touches all 4 points. So any chord subtends equal angles. So you might remember, if I just draw it quickly, you might remember this shape. Okay, so this is a cyclic quad, right? But if I do this, then we know that those angles are equal because they are subtended by this chord on the circle. So therefore they will be equal. So that's another thing to do, is to look for angles in the cyclic quad that are subtended that we know are equal. And this is the winner for this particular one. Okay, because we know that A1, I'm pointing at A1, we've already labeled with the blue line. But look at chord QOC. Now, it's a chord now because remember that there's a circle around this quadrilateral that we can't see, but we do know it's cyclic. So this chord is subtending A1, but it's also subtending one of the angles that we need. And we've already marked that off with an X as the angles we need to show is equal to this one. And look, we've already marked that as X. So we've actually done all the work. We just have to write it out now. Okay, so remember with my voice notes, the first was deciding what theorems you might use, and that's what I've written here, center and tangent theorem. The second was to mark your diagram with all the possible information that you can. And then the third is then you look at the question, and then you see with the connections that you've made how you can work out a path from what you've made to what the question is. Okay, so in this case, and some of it you might understand is irrelevant. I mean, you're not going to use all of it. Like, for example, we're not actually going to use the fact that these two angles are equal. Even though we've shown that they're equal, we're not going to use that. But we're going to use the fact, firstly, that this is perpendicular and that's perpendicular, because that enables us to say that the quadrilateral AOCQ is cyclic. Then we're going to show that within the cyclic quad, this angle A1 equals that angle Q1 because the angles are angles in the same segment. Then we're going to say, but hang on, A1 equals C1 because of tan chord theorem. See how we're going back to the theorems all the time? And C1 equals P because of our isosceles triangle, BP is given that it's equal to BC. And then we've already shown that P is equal to Q1, therefore OP is equal to OQ, and the reason is angles opposite equal sides. Or if you say isosceles triangle, it really doesn't matter. Okay, so let's go. So our first thing was that OC was perpendicular to PQ, or PC, doesn't really matter. Okay, and then the reason, don't forget the reasons, is that the tan is perpendicular to the radius. And then similarly, OA is perpendicular to PQ. And same reason, tan perpendicular to radius. And then we can conclude that AOCQ is cyclic. And the reason for that is the opposite angles are supplementary. All right, and now that we know it's cyclic, we can then state that we can start going into the actual proof. All right, and that is firstly that A1 equals Q1. All right, and that's angles in same segment, because now we know that it's cyclic. All right, and if A1 equals Q1, we also know, and this is where I say try and link those angles. So now you're looking at the angles you've already made. We've said A1 equals Q1. Now what else have you already written that A1 equals? A1 equals C1, A1 equals this, but this equals A1 because it's equal to that. So the obvious connection is A1 and C1. Okay, so therefore A1 equals C1, and the reason for that is tan chord theorem. Okay, because look, here's the triangle inside the tangent. All right, and this angle C1 is equal to A1, the opposite angle. And this is that, remember, like I told you, if A equals B and A equals C, then B equals C. So A1 equals Q1, A1 equals C1, therefore Q1 equals C1. Now let me just redo that. So Q1 equals C1. You don't need a reason for that because it's obvious. You've already given the two reasons for the first two conditions. Okay, but we also know that P is equal to C1, and that's isosceles triangle. And isosceles triangle, we know that that's equal because the lines are given as equal. So we can then make the conclusion that if Q1 equals C1 and P equals C1, that therefore P equals Q1, and that you don't need a reason. But if P equals Q1, that means that therefore OP equals OQ, and that's the proof. And the reason is angles opposite equal sides, or isosceles triangle. Okay, I hope that helps.